Hi. For those of you who don't know me, I'm Mr. Mitchell. Today we are going to be focused on the egg drop. So we'll get started. You are going to be working against gravity today. Let's see if I can switch this to full screen view. There we go. So, why are we dropping eggs is a good question. In science, frequently use models to predict outcomes of much larger situations, and because we do this because those situations would be not impossible, but infeasible, kind of silly to test. So, big, expensive, dangerous. For instance, the egg drop is an experiment that frequently uses, physicists have been using to test how spaceships descend as they approach Earth. You can see how testing these things on a spaceship would be rather costly. You need to have a spaceship, but I mean an egg and some materials and a height for a model, that's something we can do. That's why we're doing it. So using this model, physicists can get data to allow themselves to create different ways of, bringing astronauts home from orbit safely. That is what you are modeling today. So if we look here, here is a model of the Apollo 11 splashdown. 15, call me a liar. Should look fairly similar to things you have seen as it comes all the way down. I'm not going to make you watch the capsule splash down, but on the right we have someone's experiment.
It's going.
He is not going to drop it as far as we dropped ours. He's going to walk up his stairs. Very awkwardly. And do something very similar to what the Apollo did. I don't want to skip it. I want to get you the payoff of seeing it actually hit the ground. And that is the reason that I have. Well, you'll see. So we can do very similar things to space shuttles we've seen, or we can come up with something completely different. So generally when you drop eggs from a height, you will see they are not particularly sturdy. They generally break. Today, we need to stop them from breaking. So what sorts of things do we need to understand to stop these eggs from breaking when they hit the ground? Well, in general, the most basic idea is potential versus kinetic energy. After that, momentum, force, and inertia kind of help us out understanding this concept, and drag and air pressure are big. If we want to incorporate a parachute, we'll get there. So, as far as understanding potential and kinetic energy, potential energy is how much energy something might have. In our case, this is given to us by how tall we drop the egg from and gravity as it comes down. At its start, at the very top before it is let go, it only has potential energy. It's all ready to go. By releasing the egg, it slowly picks up speed, gaining energy from moving. It is proportional to the potential energy. You don't have a problem when the egg has all this kinetic energy in it as it's going down. The problem is when it hits the ground. The kinetic energy needs to go somewhere. I have found a very excellent NASA scientist by the name of Mark Rober, who explains this problem with an excellent visual. So I'm going to play that for us.
So at the start of your drop, your egg is up high and it's stationary, so it has potential energy, which is the energy associated with height. So these red blocks represent the potential energy. And the higher I go, the more blocks of energy I start with. And then as the egg falls, that potential energy is converted to kinetic energy, which is the energy of speed. So you start up high, and every single block is over here as potential energy. But as you start to fall and fall faster and faster, every single block comes over here as kinetic energy, or speed. And now your egg is about to impact the ground and has all this energy in the form of speed that's got to go somewhere. Now this broom represents the standing energy that holds an eggshell together and makes it hard. So the way to think about this is when your egg hits the ground, if you introduce more energy than the binding energy of the molecules holding the hard eggshell together at any point, you're going to break at that point. So the question then becomes, what can we do to keep our blocks below the broom? Because simply put, below the broom, your egg is safe. Anything above the broom, and your egg is busted. Well, there's two things we can do. The first is that we can make this pile of green blocks not as tall. This is why no matter what your contraption is to protect the egg, if your rules allow it, you should make a parachute. The bigger the better. And it does not have to be fancy. This is like old school army guy style. Just cut up a trash bag, a little bit of string, a little bit of tape. And just looking at this, you can see the difference a parachute can make. So the second thing you can do is not to remove any green blocks by reducing your speed, but to spread them out. So if we say left to right is our time axis, the more we can stretch out this impact event, the more we can lower that high energy spike. And this is a cool way to think about any two objects impacted. The longer the duration of the impact, the more you can spread out that force so stuff doesn't break. So for example, this is the point of car airbags. Instead of your head hitting the steering wheel and stopping near instantaneously, it stretches out the impact force over time so you don't get a quick spike that exceeds the broom line for your skull. This is exactly why long jumpers prefer to land in sand and not on asphalt, and why parkour runners will always roll after a big jump. It's all about diffusing the force over a longer period of time. So what does that mean for our egg contraptions? It's really just something to keep in mind, because it can make it more intuitive, for example, to see why putting your egg in the middle of a jar of peanut butter, which is a popular and not a very good idea, isn't as good as putting your egg in the middle of a popcorn ball. Okay, back to the bridge.
So, he gave us a lot there, but the general concept is that the whole key to keeping this egg alive is to keeping that potential energy from quickly transferring back into the egg and exceeding its strength limit. How do we do this? Well, he threw out an idea of a parachute, and we'll get back to that. But you are going to be building something to stop this from happening. Think about it in this way. The egg, as it's falling, is gaining momentum. How hard the container and the egg is going to hit the ground, right? That you can't be helped. It's a force, the strength with which it's moving, how hard it's going to hit the ground. It's going to hit the ground now. The object has a certain inertia as it's coming down. It doesn't want to turn around and go the other way, so that force is going to be disruptive as it goes back through your container. Now, what does this mean for you? Well, you only have to save the egg. So, incorporate things into your design that reduce that impact, that make it hit slower, that redirect that energy around the egg. If you can design a structure where the energy from the impact with the ground does not go directly into an egg, that's a big deal. If the egg doesn't absorb that force cannot crack the egg. If you have things around on your container that will absorb some of that force, take it away from the egg, that will also help it out. Think in that way. Reduce the force, redirect the force, and absorb the force. The last bit, he talked about a parachute. This is not a bad idea. In fact, this is a good idea. But this cannot be the extent of your thought process. How do parachutes work? Well, parachutes work on the concept of drag. When things fall or move through a liquid, they slow down. They can't use all of their force to move because the force of the liquid stops them. For some strange reason, air also acts like a liquid, probably because of all the water vapor it has in it and other things, and the way the molecules bind together. So you can introduce things to increase this force of drag and prevent all of that kinetic energy from transferring directly into speed, right? So if you make use of drag and air pressure, you can slow down that energy transfer from potential to kinetic and slow down and save your egg. But don't be fooled. A parachute on its own is not going to be enough to save this egg from cracking. Parachute alone is not going to, unless it's a very well designed, very large parachute, it's not going to stop the egg from breaking. You need more than that. So, what do we have? Well, so today you are going to be building a model space capsule. With the materials provided or things you brought from home, model building this capsule for a spaceship. The egg is going to represent the astronauts coming back to Earth after their lengthy trip. To make this model more accurate, since the egg and lander are much, much smaller than they would be in real life, and the materials are much different, we're only going to be dropping this container from about 25 feet out the window up here. It's your job to make sure that everything makes it to the ground safely. As this is a competition, it is your job to know the rules. What are the rules? Well, they are in the next video.